Is Iceland an energetical model to follow?
Iceland is the youngest European land, and it's also one of the most hostile. It is deprived of fossil fuels and any other sources of non-renewable energy. But it's also a formidable territory rich in heat and water in every form. To settle here, so close from the Arctic Circle, Icelanders were forced to exploit the heat of the ground and the abundance of flowing water. Our project will focus on geothermal energy. At first, here's a quick summary of the history of this energy. Between the 9th and the end of the 19th century, hot springs were considered as an heavy god manifestation, used for leisures as pools and baths, used for cooking, washing and gardening in houses, and finally used for medicine as cure.
During the first part of the 20th century, houses were heated with coal and fuel. In parallel, in 1892, the first geothermal heating system was built in the USA. Young Icelanders came back with new relevant ideas for exploiting hot springs. Ever since, geothermal energy developed in house heating, and eventually the oil crisis in 1973 accelerated the energy transition. Nowadays, 90% of houses are heated by geothermal areas.
Geothermal areas are situated at plate boundaries and above hotspots. This determines whether a country is able to exploit this kind of energy or not. Let's ask ourselves, how does a geothermal power station work? Our support will be the example of Orkanataruna, situated 27 kilometers southeast of Reykjavik, which opened in 2006.
It all starts with a borehole that reaches up to 3 kilometers deep and extracts water and steam at 300 degrees Celsius. After going through the separator, the steam, at high pressure, turns a turbine which itself acts on a generator. This circuit produces most of the electricity which is then sent to inhabitants. The hot water separated for the steam is cold clean water which is then sent to consumers. To make the power station more efficient, they added several components. The hot water passes through another separator, which again extracts the remaining steam at a lower pressure. By the same principle as the first circuit, it produces 10% of the electricity. A condenser uses the steam to preheat cold water. Then, the steam condenses and becomes water before it's sent back into the ground. Finally, a mist eliminator avoids condensation of steam in the pipes.
Actually, Icelanders only use 17% of the electricity they produce. To transport the electricity, they use high-voltage power cables. They directly run from the power plant to the substations and then to the consumers. Hot water flows through isolated pipes. Less than 2 degrees Celsius is lost between the power plant and Reykjavik. Their disposition allows the diffusion of dilatation forces. They're placed above ground as it is cheaper and makes maintenance easier. It also minimizes damage from frequent earthquakes.
Iceland attracts the greatest minds in the world, thanks to its experience and knowledge in geothermal power station. As Björn explained to us,
we are now working in 63 countries building geothermal power plants. We have a huge of them in Mexico, we have in Indonesia, we have in Italy, we have in the Caribbean Ocean. And now it's a huge business for us to export knowledge. And we've been working a lot in Africa as well. The problem is, and you get a bit tired of it after many years. Even it's nice to live in the Caribbean for a few years and Congo for a few years, and Indonesia. So those countries do not have money to do anything else.
In conclusion, Iceland is, with Italy, a pioneer of geothermal energy exploitation. It seems hard to reproduce this model worldwide. Nevertheless, parts of it can be adapted in other geothermal areas. People come to be taught, and Icelandic engineers are hired abroad to develop those systems in other countries.